Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy, and today I'm going to answer the question, what is demand control ventilation? I've discussed ventilation air in the past, but let's do a quick refresher. Ventilation air is the fresh air that you bring in from outside a building for indoor air quality. ASHRAE Standard 62.1, Ventilation for Acceptable Indoor Air Quality, tells you how much ventilation air you need to bring into a space based on the size and occupancy of the space. For instance, ASHRAE 62.1 says that a classroom needs 10 CFM per person plus 0.12 CFM per square foot, and a cafeteria would need 7.5 CFM per person plus 0.18 CFM per square foot. So if we have a classroom that's 30 by 30 with 30 kids in it, that would be 30 by 30 equals 900 square feet times 0.12 plus 30 kids times 10 CFM is 300, and that gives you 408 CFM of fresh air. And for the cafeteria, let's say it's 50 by 100 with 800 kids in it. So that'd be 50 times 100 is 5,000 square feet times 0.18 plus 800 kids times 7.5. And that comes up to 6,900 CFM of fresh air. Okay, so let me make a little room here. So now let's look at the classroom. So the classroom probably stays pretty consistent with the 30 kids in it. If we assumed 1 CFM per square foot, to make the math easy, the classroom would need 900 CFM to handle the load. Of that, 408 CFM would need to be fresh air, so 408 divided by 90 is about 45% fresh air. Because the room occupancy is consistent, you could set an outside air damper to provide 45% outside air all the time, and that would pretty much take care of the space's needs. Now let's use our 1 CFM per square foot again on the cafeteria. That would give us 5,000 CFM for the load. But since we need 6,900 CFM of fresh air, we would bring 6,900 CFM into the space instead of just the 5,000. But the cafeteria will spend a big part of the day empty or with just a few people in it. So this is where demand control ventilation comes in. Demand control ventilation is adjusting the ventilation air in a space to meet the occupant demand. So in the cafeteria, if there were no occupants, you wouldn't need to bring in the full 6,900 CFM of fresh air. So let's look at why you want to vary the ventilation air based on demand. So let's make a little more room and draw an air handler. Let's make some openings for our outside air, return air, and supply air. So our fan is here. It's kind of a horrible fan, but you get the idea. And this will be our supply air going to the space. Down here is our return air, and over here is our outdoor air. So the supply air you want to send to your space is about 55 degrees and 55% relative humidity, we'll say. Your return air coming back from your occupied space is about 75 degrees and maybe 60% relative humidity. And now your outdoor air, if it's summer, could be 90 degrees and maybe 80% relative humidity, depending on where you live. And in the winter, it could be 40 degrees and maybe 50% relative humidity. So this means that in the summer, if you bring in 6,900 CFM of outdoor air all day to the cafeteria, you'd have to cool it all down to get to your 55 degree, 55% humidity. Or in the winter, if you brought in 40 degree air, you'd have to warm it up to get it to the 55 degree air to supply it to the space. Both of these would be wasting energy for most of the day since the cafeteria is unoccupied. So using demand control ventilation, you can determine occupancy in the space and control the ventilation air based on that. And there's a couple ways to determine the occupancy. You could just program in the lunchtime cafeteria schedule and bring in ventilation air just during those times. You could have an occupancy sensor to sense when there are occupants in the cafeteria, or you could use a CO2 sensor to sense that there are occupants in the cafeteria as well. This way you only supply ventilation air when necessary, which saves energy and saves money. So that's demand control ventilation, and thanks to James who suggested the idea for this podcast over Twitter to me. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.